One way that we can visualize correlations between two variables is by a scatter plot or a scattergram. And essentially, each dot represents each person's score on the axis. So then our x-axis is going to be our x variable or our independent variable, or our y-axis for our y variable, also known as our dependent variable. And if we look at this first one here, notice that as we move to the right on our x-axis, what happens to all of the dots? The dots tend to move up, right? So if you think about our y-axis, as long as we move up our y-axis, what's happening to the x variable? So as we move up our y-axis, what's happening to the dots? They're moving to the right along the x-axis. So as our x goes up, so does our y. So this is going to indicate to us a positive correlation. And this is going to be a strong positive correlation because we want to look at how clumped, how clustered, or how spread out are these dots. The tighter they are to signify a line, the stronger the relationship. Conversely, what do we see here? As we move to the right on x, what's happening to y? Both scores are going up, right? As we move to the right, as we go up on our x-axis, our y variables, or y scores, are also going up. So this is also indicating a positive relationship, but notice how more spread out each of these dots are relative to our first graph. This is going to indicate visually a moderate positive correlation. And look here. Can you make out if there's a line anywhere? It's really just a big blob, right, of dots. In this case, because there is no line that we can make out of here, there really is no correlation. So if it's just a big scatter plot of just dots randomly spread out and you can't really make anything of it, it's probably a good indication that there's no correlation, that there's no relationship between variable x and variable y. Look at as you move to the right on x, we see we have some scores that are really high, some scores that are really low. And if you move up on the y-axis, notice that we have some excess, we have some dots on our x that are to the left and to the right. So it's all over the place. There really is no pattern. There's no trend here, so it's no correlation. Conversely, notice what happens as we move along our x-axis, what happens to our scores on our y-axis. As we move to the right on x, our scores are tending to go down on y. Conversely, as we go up on our y-axis, our scores tend to move closer to 0 on our x. So we actually see a negative correlation. And again, looking at how dispersed, how spread out, or how tightly knit these dots are indicate strength. Compared to here, moving in the same direction, essentially going to demonstrate to us a strong negative correlation. So we really want to look to see what's happening on our x and our y axis and what's happening to the dots to see whether or not we can come up with a direction, positive or negative. But again, when we talk about the strength of a correlation, it's really based upon how tight the dots are. How clustered are they? Are they more dispersed and spread out, or are they all tightly knit together? Strength is not dependent upon the slopeness. Right? If we have a flat line compared to a really steep line, it's not really going to dictate strength. It's more upon how tightly knit are these dots. Another way that we can illustrate and show relationships between variables is by creating a correlation matrix. Notice for each column we have income, education, attitude, and vote. We have 4 different variables. Now look at the 4 rows: income, education, attitude, and vote. These are the exact same 4 variables that we see in our columns. And when we think about correlation coefficients, it's describing 2 variables. It's a bivariate relationship. But we have 4 variables here. One of the nice things about correlation matrices is that we can show and demonstrate in a nice, clean, and organized way multiple bivariate relationships. Notice, if we look just at the column for income, we see that we have 4 correlation coefficients: 1.574, negative 0.08, and negative 0.291. We can see the relationships that each of these 4 variables have with income. But look at income and income itself. It's a perfect 1. Remember I mentioned you're never going to find a perfect relationship really anywhere. But why do we have a 1 here? And notice we have 4 1s all along this nice diagonal. So why is that? Well, notice that each of these perfect correlations are when we have the relationship between the exact same variable. So of course, if we're looking at the exact same variable, we should expect to see the exact same thing, right? Looking in the mirror. So in this case, income, well, with the exact same income and the exact same data, is then going to say that yes, there is a perfect relationship. So really, this diagonal here doesn't really tell us much. But we can see for income the bivariate relationships with the other variables. So this is just one nice, concise, organized way of showing multiple bivariate relationships. Here is another correlation matrix, but this is one that SPSS will actually give us. We will tell it to actually give this to us, but this is the output that we will actually get. And this is going to look very similar to what we saw previously. Notice all of our 1s, perfect relationships, and these are all for each of these 6 variables. But notice in this bottom triangle and this top triangle, look at the relationships. You notice anything? These are essentially mirror images of each other. Right, if you just take a look at this row, age when you first drink alcoholic beverage. The relationship between drinking for the first time and smoking a cigarette for the first time, R is equal to 0.452. Well, let's look at the first column, drinking alcohol, and looking at the second row, smoking a cigarette. We see the exact same number, 0.452. So as much as these correlation matrices may feel very overwhelming with all the different numbers and all these different rows and columns, rest assured that it's going to be okay because it's pretty much a duplicate. We see the same information twice. So all I really need to focus on is the bottom triangle or the top triangle.